Okay, so as you can see right here, you have three different quadratic expressions, but we're going to assume that these are all equal to 0, so we're going to equal them to 0 and see them as equations. So what I want you to see here is that the only thing that changes here is the c value. So you have 24, 25, and 26. So your a equals 1, your b equals 10, and your c equals 24. And then for the second one, a equals 1, b equals 10, and c equals 25. And the last one, a equals 1, b equals 10, and c equals 26. Now the thing about this is we're going to go one at a time. So I'm going to go and I'm going to just look at the discriminant. Why? Because that's the only thing that matters. If you notice, every equation is going to have this part the same and this part the same. So for now, I'm going to ignore that and I'm going to only look at the discriminant, which is this part right here. The part that's going to change, because that's the only part that has the c value, which is the only thing that changes in these three things. So what I'm going to do is I'm going to substitute that. So I'm going to get 100 minus, and then that's 4 times a, which is 1, times c, which is 24. And in this case, I get 100 minus 96. And then I get 100 minus 96, which is 4. So if I substitute that value inside of there, I'm going to get a value which is negative 10 plus minus the square root of 4, which is 2, divided by 2 times 1, which is 2. Now if I add, that's the same thing as negative 10 plus 2 over 2, and negative 10 minus 2 over 2. And as you can see, this gives me two distinct real numbers because they're real. If I add 2 to negative 10, I get a positive 8. Divided by 2, that's 4. If I subtract 2 from negative 10, right here, I get negative 12. Divided by 2, that's negative 6. So I get two distinct real numbers. And that all happened because this value right here, the discriminant, is positive. Now, if I go to the same problem, but I look for my discriminant here, I get that b squared, 100 again, minus 4 times a, which is 1, times bc, which is 4ac, which is 25. I get 100 minus 100. That's 0. Now what happens there is that the square root of 0 equals 0, right? So I get the same thing as I did before. This is negative 10. This is negative 10. So I'm going to get negative 10 plus 0 divided by 2. And I'm also going to get negative 10 minus 0 divided by 2. So that gives me negative 5, and that gives me negative 5. Sure, I did it twice, but in the end, I get one value, which means that if my discriminant is 0, then I only get one real value. And you saw that it's real because I didn't add anything that's imaginary. So let's look at our final one. I'm going to look again at that discriminant, and I'm going to go b squared, which is 100, minus 4 times 1 times 26. Now, 4 times 6 is 36. No, nope, I messed up. 6 times 4 is 24. So that's it. 2, and then 4 times 2 is 8, 104. And so I get, I think that's correct, I get 100 minus 104, and that's negative 4. Now here's where it gets tricky, because you get the square root of negative 4. And we've talked about this. You can't get a square root of negative number. You're always going to get a 2i, because 2 times 2 is 4, so you get the 4. But this is a negative. Nothing's going to give you a negative. That's an imaginary number. So basically, you're going to do that twice. You're going to get the negative 10 plus the 2i over 2. And you're going to get the negative 10. I'm just going to divide that so you can see that. Minus the 2i over 2. Which gives you those two solutions, but they're not real. They're imaginary. And that's because your discriminant was negative. So those are the three different distinct positions, and that's why it happens. And I showed it to you using very similar equations because I wanted you to see the distinction between those discriminants as clear as possible. So I hope this clarifies that. And if you have any other questions, just post them to the classroom in the questions thread. Thank you.